session. In this session, we're gonna go about how to create a project with Simplicity Studio 5. And we're gonna do that by creating a very simple project. All our code is going to do is light up a single LED. And of course, you can use the knowledge gained from this session to build more complex programs and more meaningful code, and we'll do that in future sessions. But just to get a quick understanding of how to start a project in Simplicity Studio 5, I think this video might be helpful. So first off, you're gonna start Simplicity Studio 5 and go to the launcher, and now you're gonna want to plug in your development kit and wait for it to be discovered. You see it has been discovered. We're gonna go click on start. So here it's gonna give us some overview of which board was detected, which microcontroller is on the board. So here you see I'm using the EFM8BB3 starter kit, which is short BRD5202A, and you can see a lot of documentation here. Of course, this always takes a little bit of time since it needs to load all the data from the internet, and I would highly recommend you to look into this, as this is the exact reference manual and datasheet that you're gonna need for your microcontroller. So you won't go through the hassle of Googling it and finding the wrong reference manual. So from the overview, we go to create new project. It's gonna start the project wizard. The wizard is gonna detect our board and specific microcontroller again. This may take a little time, but it should soon be finished. Yeah, so it takes us right to the examples, but let's go back one step just to confirm the settings. We see target and software development kit. We see it has correctly discovered our kit, or my kit. It has correctly discovered the microcontroller, the SDK and IDE and toolchain. You can leave it as is. Click on next, and here you can also start from a lot of very well documented examples, but we're not going to do that right now. Right now we're going to create our own project from scratch. So click empty C project, click on next. We're going to name it, let's name it session 1. We're going to use the default location, this is, click on finish. This is going to create our empty project. And now we see it has created our project. It has created the main, but nothing more. And what we're gonna do now is create a configuration file. So we're gonna go to source, click on the folder, right click, go to new. We're gonna go to other, and we're gonna go to Simplicity Studio, Simplicity configuration document. We're gonna go to next. We're gonna leave it as is, click on finish, and this will create a configuration document. This is just a way to quicker and simpler configure the GPIO pins as well as the peripherals of our microcontroller. But you will see all that in a minute, after my PC is faded. So here we see our microcontroller, we see all the pins, and the important windows you need to know is the default mode port IO, where you're gonna configure the GPIO, and the default mode peripheral, where we are going to configure all the peripherals, such as the watchdog, timers, communications, so SPI, I2C, UART, analog, ADC, and so on. But for now, let's just start with configuring our GPIO. And what is most important is that you click on port IO and enable crossbar. Without enabling the crossbar, nothing is going to work. So now it is enabled, and now we are able to configure our GPIO pins. And in my case, on port 1, pin 4, there's LED 0 of the development board. And I'm gonna go ahead and set this to digital push-pull output in order to be able to light up the LED. We're gonna set it to initially high, which means the LED is turned off. And if we're gonna set it to low in the code, we're gonna do that later in the code, it will light up. So yeah, crossbar is enabled. Pin port 1, pin 4 is digital push-pull output. Perfect. And what you're gonna do now is we're also gonna disable the watchdog. The watchdog is enabled by default, but don't need it now, so let's click on watchdog and disable it. Click somewhere else, watchdog enabled, you see it is disabled. Perfect. Go back to default port IO, and we're gonna click Ctrl S to save the file. This will prompt the wizard to generate code for us. Yeah, we have to wait a few seconds. This of course depends on your PC performance, and as we see now, it has created a new include folder and a new source file, the init-device.c, where you can see enter default mode from reset. This is the function we're gonna call inside main, and this function will call other functions in turn, which just is gonna go ahead and disable the watchdog and set up GPIO pins like we've configured them in the configuration file. So all you need to know is copy this prototype inside your main code at the top of the program, and you also need to include the init-device.h file where the prototypes are present. So let's go ahead and type include init-device.h, and we see unresolved inclusion. This is because we still need to set our include path, and for that you go on the project, right click, properties, and under properties C general, paths and symbols, and here we're gonna go on the includes and GNU-C, go to add, we're gonna choose a folder from our workspace, and we're gonna choose our project, which is session 1, and we're gonna click on the include folder, OK, and we see it is now in our include path. We're gonna click apply and close. Changes will be made there. Click on yes. Perfect. And you see the red highlighting is gone because now our compiler was able to find the init-device.h file. And now we have included the init.h, we've called the prototype, but we haven't yet set the LED. So if we were to compile and flash the program now, there's nothing you're gonna see. So let's set the LED 0, and for that we're going to use a macro to define a bit variable which we'll later use to access the bit in the special function register that is used to set or clear a pin. And for that we're going to use the following macro. It is called SE. Think about it. So it's called SE. Let me just copy it in. SE bit, and then we're gonna go ahead and give it a name. In our case, LED 0. We're gonna say it's the special function register port 1 and pin 4. And if you want to know what this macro is doing exactly, just go to Open Declaration, and you will see declare a bit variable in a bit addressable special function or memory space. We're going to go ahead and give the name, the address, and the bit number. And of course, this cannot be used on any memory space. Of course, the address you pass here must be a special function register address. So, yeah, my PC just hung up for a moment. And we're back in main. So now we have declared our bit variable LED 0, which is used to access pin 4 of port 1. And all we need to do now is set this exact bit to 0 in order to light up the LED. So we're going to press Ctrl Save. We're going to click on our project, close this project. We're going to click Build. You see it's finished, 0 errors, 0 warnings, perfect. Now we want to flash our program. So we're gonna go and click on our project, right click, run as, Silicon Labs, 51 project. And now it has flashed the program, and you should see your LED light up. And that's it for this session. In the next sessions we're gonna go ahead and use timers, interrupts, and do a lot more interesting stuff. But this was just the basics, just to give you a quick overview of how to start a project from scratch, what you need to do, and get a little bit more comfortable with ACS5.